Carbon steel, properties, examples, and applications. Carbon steel is an iron-carbon alloy, which contains up to 2.1 weight% carbon. For carbon steels, there is no minimum specified content of other alloying elements, however, they often contain manganese. The maximum manganese, silicon, and copper content should be less than 1.65 weight%, 0.6 weight% and 0.6 weight% respectively. Types of carbon steel and their properties. Carbon steel can be classified into three categories according to its carbon content: low carbon steel, or mild carbon steel, medium carbon steel and high carbon steel. Low carbon steel. Low carbon steel is the most widely used form of carbon steel. These steels usually have a carbon content of less than 0.25 weight%. They cannot be hardened by heat treatment to form martensite, so this is usually achieved by cold work. Carbon steels are usually relatively soft and have low strength. They do, however, have high ductility, making them excellent for machining, welding and low cost. High strength, low alloy steels, HSLA, are also often classified as low carbon steels, however, also contain other elements such as copper, nickel, vanadium, and molybdenum. Combined, these comprise up to 10 weight% of the steel content. High strength, low alloy steels, as the name suggests, have higher strengths, which is achieved by heat treatment. They also retain ductility, making them easily formable and machinable. HSLA are more resistant to corrosion than plain low carbon steels. Medium carbon steel. Medium carbon steel has a carbon content of 0.25 to 0.60 weight% and a manganese content of 0.60 to 1.65 weight%. The mechanical properties of this steel are improved via heat treatment involving austenitizing followed by quenching and tempering, giving them a martensitic microstructure. Heat treatment can only be performed on very thin sections, however, additional alloying elements, such as chromium, molybdenum and nickel, can be added to improve the steel's ability to be heat treated and, thus, hardened. Hardened medium carbon steels have greater strength than low carbon steels, however, this comes at the expense of ductility and toughness. High carbon steel. High carbon steel has a carbon content of 0.61.25 weight% and manganese content of 0.30 to 0.90 weight%. It has the highest hardness and toughness of the carbon steels and the lowest ductility. High carbon steels are very wear resistant as a result of the fact that they are almost always hardened and tempered. Tool steels and die steels are types of high carbon steels, which contain additional alloying elements including chromium, vanadium, molybdenum and tungsten. The addition of these elements results in the very hard wear-resistant steel, which is a result of the formation of carbide compounds, such as tungsten carbide, WC. Production and processing. Carbon steel can be produced from recycled steel, virgin steel or a combination of both. Virgin steel is made by combining iron ore, coke, produced by heating coal in the absence of air, and lime in a blast furnace at around 1650 degrees Celsius. The molten iron extracted from the iron ore is enriched with carbon from the burning coke. The remaining impurities combine with the lime to form slag, which floats on top of the molten metal where it can be extracted. The resulting molten steel contains roughly 4 weight% carbon. This carbon content is then reduced to the desired amount in a process called decarburization. This is achieved by passing oxygen through the melt, which oxidizes the carbon in the steel, producing carbon monoxide and carbon dioxide. Examples and applications. Low carbon steel. Low carbon steels are often used in automobile body components, structural shapes, I-beams, channel and angle iron, pipes, construction and bridge components, and food cans. Medium carbon steel. As a result of their high strength, resistance to wear and toughness, medium carbon steels are often used for railway tracks, train wheels, crankshafts, and gears and machinery parts requiring this combination of properties. High carbon steel. Due to their high wear resistance and hardness, high carbon steels are used in cutting tools, springs, high strength wire and dies.